Hey guys, Jacob Howard here, and welcome to this video where we are going to talk about the motors on your drone. Selecting the correct motors is key to obtaining the right performance for your drone. Motors can be optimized for long-range efficiency, racing, freestyle tricks, tiny whoops, and much more. Using the wrong type of motor can lead to underperforming quads and maybe even ruining sensitive components of your drone, costing you money. Let's take a look at each of the various metrics you need to understand to really get a grasp on how FPV drone motors work. In a nutshell, motors rotate your propellers to create movement. They are typically made of aluminum, steel, titanium, or even a combination of these. There are two types of motors used in virtually all drones, brushed and brushless motors. We will cover the intricacies of these in a little bit. However, they each have three main components: the shaft, the rotor, and the stator. Now, on top of the components, each type of motor works on something called electromagnetism. Let's look at that real quick before we jump into the rest. Whether you are using brushed or brushless motors, the principle of electromagnetism is at the root of your motor's functionality. An electromagnet in a drone motor is made up of a metal core surrounded by copper windings, which can be activated and deactivated by passing electrical current through it. This then interacts with magnets that are positioned around the metal core. As electricity pulses through the metal core, it turns the magnets, which changes the electrical energy from your battery into kinetic energy in the form of propeller movement. Let's break it down into the various parts of the drone motor though. The shaft is at the center of the motor and is what you attach your propellers to. The rotor and stator are then attached to the shaft. The stator surrounds the shaft in coiled copper wire. As we just talked about, these wires are used to send electrical currents that interact with the last part of the motor, the rotor. The rotor is the outside part of the motor and is often referred to as the motor bell or can. On the inside of the rotor though, there are small magnets. These magnets are what interact with the electrical pulses from the stator, and as they do, they begin to spin the rotor and thus the shaft, which spins the prop. Now, as we said, there are two main types of motors that both use electromagnetism: brushed and brushless motors. Let's look at these. Brushed motors. Brushed motors typically look long and cylindrical and are normally fairly small. Their uses in drones have decreased over the recent years and were much more popular in the past. However, they are still used and for many reasons are well suited for micro drones like the Emax Easy Pilot. Brushed motors are very well contained, meaning that the only moving part of the motor is the shaft exiting the motor can. This works well to prevent damage to sensitive components, but also decreases efficiency since the enclosed motor housing can cause overheating. For brushed motors, the copper coils are in contact with the brushes, which also causes quicker failure. For these reasons, brushed motors are not ideal for anything larger than a very small drone, such as a tiny whoop. Brushless motors. Brushless motors typically have a short and wide cylindrical shape and can vary greatly in size. As their name suggests, brushless motors do not make contact with the magnets on the stator. This prevents the motor from wearing out due to friction between the brushes and the magnets, which increases the life of the motors greatly compared to brushed motors. However, the motor bells on a brushless motor are exposed and can be damaged or dented in a hard crash, which could lead to an entire motor replacement. These motors come in various sizes and can serve various purposes, including tiny whoops such as the Emax Tiny Hawk, and larger drones like X-Class racers, which can spin up to 30-inch propellers. Size. Drone motors come in various sizes for different applications. There are a few important numbers to understand when selecting motors. Just like with the props, drone motors have an identifying number system of 4 digits to indicate their size. To use an example, we will look at the Emax Pulsar 2306 motors. The number 2306 describes the size of the stator, the first two numbers 23 referencing the diameter in millimeters, and the second two 06 referencing the height. So for these motors, we have a stator of 23 millimeters in diameter and 6 millimeters tall. The reason this number is important is because different size motors have different performance characteristics. For a standard 5-inch build, you will usually see motors with diameters ranging from 22 to 24 millimeters and heights from 5 to 8 millimeters. The most common reason to change your motors is to adjust from a quick and nimble drone to more of an efficient cruiser or vice versa. Typically, motors with smaller stator size, 2206 for example, will be very capable of changing speeds quickly and handling high speeds and high-pitched props. Motors with larger stator sizes, 2408 for example, will require more energy to change their momentum, but will be very efficient once at a cruising speed. These numbers will also give you a feel for how heavy the motor is. The larger the motor, the heavier it will typically be. This correlates with the rule we discussed earlier. The smaller the motor, the more nimble it will be, but the more power it will draw to keep your quad going. Motor speed. The second number used to identify as motors is the kV. Motor kV is a number which identifies the constant velocity of a motor. It is measured by the number of revolutions per minute, RPM, that a motor turns when 1 volt is applied with no load attached to that motor. It might be tempting to think that the higher the kV, the faster a motor will spin, and while this is accurate in most situations, it is not always true. For example, if a 2400 kV motor is used on a 4S LiPo battery, which has a nominal voltage of 15.2 volts, the motor will spin at a max RPM of 36,000 without a load. But if we pair a lower kV motor, for example a 1600 kV motor with a 6S LiPo battery, nominal voltage 22.8 volts, the motor will also spin a max RPM of 36,000 without a load. Pairing the correct kV with the correct prop to achieve the desired results can be tricky. Matching the correct propeller dimensions to the correct motor is extremely important. Motor kV is the most important factor to take in consideration when determining propeller pitch. For example, you might pair a motor with a higher kV and a lower pitch prop, or a motor with a lower kV with a higher pitch prop to get different flight characteristics. It is also typical to see smaller drones paired with higher kV motors since it is easier to spin a shorter propeller, and because small props create less thrust, therefore a higher motor kV is important to keep the drone up. Mounting patterns and thread size. Motors will in almost all situations be fastened to the drone frame through 4 screws. The industry has become fairly standard in that frames of a given size, 5-inch for example, will be compatible with corresponding 5-inch motors and their mounting patterns. However, before buying motors or frame, it is valuable to ensure that they are compatible. The dimensions can be found in the specifications for the motor and frame. An example of a common mounting pattern is 16mm by 19mm, meaning the mounting holes make a small rectangle of sides 16 and 19mm in length. It is also advisable to check the thread size for the screws holding the motor to the frame. Typical for 5-inch drones is an M3 screw. It is essential that motors are carefully selected with adequate specifications for what you're going to use it for. We will be giving you our best recommendations for motors on the drones we will build in this course, but don't let that stop you from exploring with other motors and configurations to get what will work best for you. If you enjoyed this video on FPV, we actually have an entire online course developed around these same types of lessons. We're talking dozens of lessons and hours of material designed to get you started into FPV or make you a better pilot. It is the world's first online FPV course, and we have students from around the world learning through it. The link to learn more is in the comments below. And as always, if you guys have any questions, definitely let me know, and have fun flying.